Hello, welcome to Object-Oriented Programming. My name is Ashkur Rahman and I am a student of Daffodil International University. Java uses object-oriented programming, a programming style that is intended to make thinking about programming closer to thinking about the real world. In object-oriented programming, each object is an independent unit with a unique identity, just as objects in the real world are. An apple is an object, so a car is. Each has its unique identity. It's possible to have two apples or two cars. They look identical, but they are still separate, unique objects. Objects also have characteristics, which are used to describe them. For example, a car can be red or blue. An apple can be sweet or sour. These characteristics are also called attributes. An attribute describes the current state of an object. In the real world, each object behaves in its own way. The car moves, the phone rings, and so on. The same applies to objects. Behavior is specific to the object type. In object-oriented programming, every object has three properties. Identity. Every object should be uniquely identical. Attributes. Describe current state of an object through variables. Behavior. Demonstrate through methods. There are also class. A class describes what the object will be, but separate from the object itself. In other words, classes can be described as blueprint for those separate objects. We can use same class as a blueprint to create multiple objects. Each class has a name and used to define attributes and behavior. In a simple word, an object is an instance of a class. There are four core concepts in object-oriented programming: encapsulation, inheritance, polymorphism, and abstraction. The idea behind encapsulation is to ensure that implementation details are not visible to users. The variables of one class will be hidden from the other classes, accessible only through the methods of the current class. This is called data hiding. To achieve encapsulation in Java, we have to declare class variables as private and have to provide public setter and getter methods to modify and view the variables' values. Encapsulation provides benefits like control of the way data is accessed or modified, more flexible and easily changing on code, ability to change one part of the code without affecting other parts. Let's get into a practical approach. That's why it will be very easy to understand how really an encapsulation is. Alright. To achieve encapsulation in Java, first we have to create a class or object in Java to be class an object. So I can say new class, and I'm calling this class as car. I want to provide encapsulation of the car class. So I have to declare a variable as private. To achieve encapsulation in Java, we have to create a class or object. After creating that object, we have to declare a variable as private. In my case, I'm going to say private string color. So now time, color is our attribute here. After that, we have to declare getter and setters. Getters and setters are used to effectively protect our data, particularly when creating an object for each variable. The get method returns its value while the set method sets the value. So I'm going to say this as public, so public string get color. And it can return I say get getters as get color, and what get color can do is it can return color. That's it, my get getters is ready. Now I have to declare another form as setter. I'm going to say public void set color and set color has a parameter of string color. Okay, I'm going to see this as 3. Now I have to there this because I'm going to set this dot color equals 0. That's it, my object is created. I have to check if it is hot. I'm going to open up my main class, so I'll be able to call that this class from there. On our main method, I'm going to say car equal new car. The new object is created. Now I wanna set the color for this car. So I'm going to say car dot set color look like red. System.out.println to see if this set method can be called get. So I'm going to say there we go. We found red. The getter method returns value of the attribute. The setter method takes a parameter and assigns it to the attribute. If you look into the car class, the keyword this is used to refer the current object. Basically, this dot color is the color attribute of the car object. The next chapter of OOP is inheritance. Inheritance is the process that enables one class to acquire the properties, such as methods and variables, of another. With inheritance, the information is placed in a more manageable hierarchical order. The class inheriting the properties of another is the subclass, also called derived class or child class. The class whose properties are inherited is the superclass, which is called as base class or parent class. To inherit from a class, we have to use the keyword called extends. Let's see a very basic example of inheritance practically. That's why it will be very easy to understand. Alright, to achieve inheritance, first we have to create parent class. I'm going to say this object as animal. Say we have an object called animal. An animal has attribute, say public ID. Then we have declare type, so public string. To make this public, my intention is to create a constructor for animal. So I'm going to say no. Okay, so everyone has a type like string, and so I'm going to say this dot id. Okay, so saying this as this dot id or I. This dot name dot name and this dot is equal. There's everything for animal. First we have an object which have attributes and have a constructor. Now my intention is to create an animal object like cat and dog, and which will be inherit these characteristics and constructor. To do that, I'm going to create another class called cat. Okay, so how we can get all characteristics from our animal class? To do that, first we have to extend that animal class. So I'm going to use extends animal. When I'm going to say that, I have to make a constructor for cat class. So I'm going to say cat and cat have attribute like same attribute string I, my string m, and I have int a. Now we have our constructor ready, so I'm going to create a super method to initiate all value from our animal class. So I'm going to say super I, n. That's it. Our class for animal and cat is created. Now we will be check it from our building method. So I'm going to say, okay, give me a cat object, cat equal new cat, and new cat have an ID called 101. We will find, okay, so 101, name this as Pushi, okay, and we say this good. That's good. Now I'm gonna bring this all information from here. So information like ID, cat.id, and then there we go. We have cat ID, cat name, and cat age. Here, cat is a subclass and animal is the superclass. That was all about inheritance. Polymorphism. Polymorphism, which refers to the idea of having many forms, occurs when there is a hierarchy of classes related to each other through inheritance. A call to a member method will cause a different implementation to be executed, depending on the type of object invoking the method. Let's see an example of polymorphism, that's why it will be great to understand. Alright, polymorphism becomes handy on when a superclass has much more subclass with the same method applied. To show an example, first create an object. I'm going to call this animal ox again. Now create a method which will be overriding over and over time. In my case, I'm going to say public void make sound I'm leaving this as empty because I'm going to override this method over and over again. To do that, first I want to say public class cat, which extends. Okay, so what is actually is extending? It's going to extend animal. Also, it's going to override the method called make sounds. I'm going to override that and say make sound. Name as okay, I'm on the look. That's fine. Yeah, now we do all this probably this class. That's cool. So I've already seen an icon on the left side. Actually it is overriding immersion. That was the cat class, which is overriding the make sound method from animal. Okay, after that I want to create another class with dog, and it can extend instance animal object. Also, you just have to override that method. So public void sound. What of the next sound can do? Alright. Here I also found an animation notation. So if it's actually overriding, whatever is overriding, it's overriding next sound and also animal class as it's extending animal. Now, to initiate this, we have to go on our main class. Now on our main class, I will say animal cat equal cat. That's fine. Now I will say animal dog. Animal dog equal new dog. That's cool. Now I want to call those methods as segments. So I can say cat dog next sound. Also I can say dog carry the right. So for cat, we are finding male, and for dog, we are finding. That was pretty basic example of polymorphism. The last chapter of object-oriented programming is abstraction. Data abstraction provides the outside world with only essential information in a process of representing essential features without including implementation details. A good real-world example is a book. When we hear about the term of book, we don't know the exact specifiers, such as the page count, the color, or the size of the book. But we can understand the idea or abstraction of a book. The concept of abstraction is that we focus on essential qualities rather than the specific characteristics of one particular example. In Java, abstraction is achieved using abstract classes and interfaces. An abstract class is defined using the abstract here. We cannot create object of that type. To use an abstract class, we have to inherit it from another class. Any other class that contains an abstract method should be defined as abstract. Alright, let's see an example of abstraction that's going to be easy to understand. To do that, first we have to create an object. So I'm going to call this animal. And this is a general class, so if we want to make this class an abstract class, we just have to remove public and have to say abstract. Now time it will be act as an abstract class. Abstract class contains a method which will be also abstract method. To that I can say abstract white next sound. Now it will be called as an abstract class. That we can create another class, then this class kept. and cat can extend now the public void next sound. The next sound contains already found an annotation, so it's saying an override annotation. We are overriding an abstract class, abstract mode, using that class. Now create another class. This is dog. We have to go on our main class. Class, we have to instantiate our object. Here it is from the result. Now the question is, yes, it's very similar to inheritance. So what's the basic difference of abstraction and inheritance is? Like if I call object animal equal animal, see, we are finding an error because we cannot instantiate the animal class. It's the idea behind abstraction. That's all about object-oriented programming. Thanks for watching.